See, suppose let's say you're connecting some component to an alternating current source. Okay. Now, as the current and the EMF both are changing at every instant of time, so taking direct formula of P is equal to V into I is not helpful, correct? So what we have to take is we have to take at that instant what is the EMF and what is the current. So let's say E is equal to E naught sine omega t and I is equal to I naught sine of omega t plus phi be the two equations of the EMF and the current. Okay. Now what we have is the peak value I naught will be E naught divided by Z, correct, where Z being the impedance, and phi is given by tan inverse of XC minus XL by R, or XL minus XC by R, makes no difference. Okay. So the instantaneous power is nothing but P is equal to V into I, which is here in this case E into I. So P is equal to E naught sine omega t into I naught sine of omega t plus phi, correct? So we need to multiply these two. Okay, see what we have E naught into I naught, we can take it out. We have sine omega t into sine of omega t plus phi, right? Now think back, go back last year trigonometric transformation formula. So we have sine C into sine D formula, right? So sine C into sine D is nothing but cos of D minus C minus of cos of D plus C, correct? So we are going to apply that here. So the equation becomes E naught into I naught by 2 into cos phi minus cos of 2 omega t plus phi. Okay. Alright, see what we are looking at is the average power over a cycle, correct? So average power over a cycle will be nothing but the average on the RHS side what you are looking at, which is cos phi and cos of 2 omega t plus phi. Now, over a period of time, meaning for one cycle, the positive half and the negative half of the cosine will cancel, correct? So what we end up is that the cos of 2 omega t plus phi will become 0. Okay, because on the positive half cycle it's positive. The same thing for the negative half of the alternating current, the same thing will become negative, meaning the overall value will become 0. So we end up with just P is equal to E naught I naught by 2 into cos phi. Okay, so we change this as E naught by root 2 into I naught by root 2 into cos phi. Okay, what is E naught by root 2? It's RMS value, right? So we have P is equal to E RMS into I RMS into cos phi. Okay, so this is the equation for the power. Now the same equation for the power can also be written as P is equal to I squared into Z into cos phi. Okay, so where here I value is nothing but the RMS value, and then Z is the impedance. Cos phi, see this cos phi is called as power factor. Okay, now we'll see there are certain cases in which how we have to use the power equation. See, cos phi, now what was phi? Phi is basically the phase angle, correct? The phase difference between E and I. Now for a pure resistive circuit, phi value becomes 0. So cos 0 is 1. Now what we get is just P is equal to V into I. Okay, so this was the formula which you guys have learned before, right? This is case 1. Now for case 2, suppose let's say we are looking at LCR circuit. Okay, in LCR circuit, let's say you are talking about the resonance condition. See, in resonance condition, XL and XC are equal, correct? So again here phi value will be 0, meaning at resonance condition the whole circuit acts like a pure resistive circuit. This is what we have discussed before also, correct? So this is case 2. Now case 3 is, suppose let's say we connect just an inductor or just a capacitor. Okay, now here the phi value is 90, correct? Now cos 90 is what? 0. So there is no power. Okay, that means a pure inductor or a pure capacitor draws no power. So there is no power. Okay, so you will understand about this just after this video. So we have something known as wattless current. Okay, so why it doesn't draw any power? So all these things you guys will learn in the next coming video. So just hold on. Okay. So remember the formula for power, which is ERMS IRMS into cos phi.